if I told you that carbon can have different weights but still be the same carbon, would you believe me? Sounds impossible, right? But that's exactly what happens with isotopes. Hi everyone, welcome to Chemistry Portal. I am Sudhanshu Kumar, and today we will uncover this mystery along with atomic number and mass number. Let's start. So first of all, we will talk about atomic number and mass number. So topic, atomic number, that is Z, and mass number, we represent the mass number by A, capital A. Okay, and suppose we have some element x, okay, some element x, and we write the atomic number in the subscript here Z, and we write the atomic mass in the superscript of this element. Okay, and this is the complete notation of symbol and atomic mass and atomic number. Okay, so let me write here, this Z is called atomic number, and this A is called atomic mass. Okay, right. Now, so first point, what is called atomic number? Atomic number is nothing but it is a number that is equal to number of protons in its nucleus. Okay, atomic number equal to number of protons in its nucleus. Very, very important. Okay, second point, atomic number equal to number of protons, atomic number equal to number of electrons also, right? Atomic number equal to number of electrons. But this is valid only for neutral atom. This is valid only for neutral atom. In the case of neutral atom, only we can say atomic number is equal to number of electrons. Okay? Okay, fine. Now let's take some example. Suppose we have carbon and symbol is C, right? And this carbon is what? Neutral, right? This carbon is neutral. No charge here, no positive charge, no negative charge on the carbon. Okay? So that's why, so how to find the number of protons and number of electrons? See here. So in the case of carbon, atomic number is what? 6, right? Z equal to 6. So number of proton equal to what? Number of proton equal to 6, because we know that atomic number equal to number of proton. So here for this carbon, atomic number is 6. That's why we can write directly here number of proton equal to 6. Okay. Now if I ask you what is the number of electron, so number of electron, that is also equal to 6, because this atom is a neutral atom, and for neutral atom we can write atomic number equal to number of electron. So basically this same atomic number will be the number of electrons also, right? Okay. Note, you must have to remember, okay? You must have to remember the atomic number and symbols of element. symbols of element up to atomic number 30. It's very important for you. Okay, you must have to remember the atomic number and symbols of the elements up to atomic number 30. Okay, I will give you some picture here. I have some table up to 20. Okay, I will paste it here. See, this is the table we have here. We have so don't see the atomic mass now. Okay, don't see the atomic mass. We just bothered about element and atomic number. Okay, so here if you see hydrogen, atomic number is 1, helium, atomic number is 2, lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, neon 10, sodium 11, magnesium 12, aluminium 13, silicon 14, phosphorus 15, sulfur 16, chlorine 17, argon 18, potassium 19, calcium 20. This table you must have to remember atomic number and the element's name with symbol. Okay, up to 30. Don't forget this. Okay, very important. Now we will talk about mass number. Okay, now we will talk about mass number. See, what is called mass number? What is called mass number? Right here. Mass number. Okay. Mass number we denote by the symbol is A. Okay. Symbol is A. Right. Mass number is nothing but sorry. Mass number is nothing but it is number of proton plus number of neutron. Number of neutron. Okay, very important. How to find the mass number? Just add the number of proton and add the number of neutron. Okay, in that atom, and that will give you the mass number of that atom. Okay, and the mass number is always a whole number. Mass number is always a whole number. Okay, and mass number we define for a specific isotope or individual atom. We will discuss it in more detail. Okay, what is called isotope and what does this line means. Okay, I will tell in very detail. Okay, so mass number is always a whole number, and mass number is we define for a specific isotope or individual atom. Right. Okay. Now here the new word came, that is isotope. What is called isotope? What is called isotope? Now we will discuss isotopes. Isotopes. Write the topic here. Isotopes. Okay. Let's start from example. Very simple example I will take here, and from the example your concept will be crystal and clear. Okay, so let's take a 3 atom. Suppose we have X. X is any atom. X. Okay, and I have taken here atom of the same element. Okay, I have taken atoms of the same element because all are the same atom, right? X. It means all the atoms here are of the same element. Okay. Now suppose this element X this element X, number of proton equal to 6 and number of neutron equal to 6. But in this atom, the number of protons same, okay, 6, but number of neutron I changed to 7. And here for this atom, same number of proton, p equal to 6, p means proton, okay, and here a small n means neutron, okay, and so, and here I changed the proton, here I changed the neutrons to 8. See here, in this atom we have number of proton equal to 6 and number of neutrons equal to 6, but in this atom same proton. See here, in all the atom I am taking here same proton, right? See here, 6, 6, 6, okay, but in this atom we have 6 number of neutron and here 7 neutron and here this atom we have 8 neutrons. It means all these atoms of the same element having the same proton but different neutron number, and such atoms are called isotopes. Okay, now write the definition. Atoms of the same element is very important word, okay. It is the key word, same element. Atoms should be of same element only, okay. So atoms of the same element and having same number of protons but different number of neutrons are called isotopes. Clear for everyone? I hope you understood, okay. See here, all the atoms are of the same element, right? X, X, X. And suppose in this atom the number of protons are 6, here also 6, here also protons are 6. In all the case here, number of protons are same, but number of neutrons are different here, 6, 7, 8. Such atoms are called isotopes. Okay, now I will copy this one again, okay. I will copy this. Now we find the mass number. What is the mass number of this atom? Very important concept will be clear from this example now I am taking here, okay. Very important. Now see, if I ask you to tell me the mass number of this atom, so I told, mass number, right? If I ask you, tell me the mass number of this atom, this atom, this atom, how you can find? Simple. I told the formula, right? See here, mass number is what? Number of proton plus number of neutron. Just you have to add the number of neutrons and number of protons. So simply do the simple math, okay. So here mass number equal to, how much for this X? 6 plus 6 equal to 12 mu, right? Okay, clear? Right or not? 12 mu, okay. Because we know that, see, one note you can write here, note. These all things we study in the mole concept, a stoichiometry, okay. But this is the video of introduction to organic chemistry. That's why I am not going in detail, okay. This is the video of introduction to organic chemistry. but still I am doing in so much depth for you. Okay, see here, write a note here, one a small note. One proton or one neutron weight is 1 mu. Okay, weight is 1 mu. Very, very important. Okay, and now you tell me here how many proton? 6. Here how many neutrons? 6. So 6 mu plus 6 mu, how much will you get? 6 mu plus 6 mu, how much? 12 mu, and that is the mass number. Okay, similarly we can do here 6 mu plus 7 mu, we will get how much? 13 mu, that is the mass number. Here 6 mu plus 8 mu, and here you will get 14 mu as the mass number. Okay, now see so here we got the mass number for this atom, that is the 12 mu, and for this atom we got here 13 mu, and for this atom we got 14 mu. Now go to the periodic table and check which atom having a proton number 6. Which atom having a proton 6. Now go to periodic table. Now let's see the periodic table. See here. First of all, I told you, right? Atomic number equal to number of proton, right? If I have to find, right, it means check the atom in the periodic table which is having a atomic number 6. Simple. If you find the atomic number, automatically you will get the number of protons, right or not? Simple, no? See here. See. This one, atomic number equal to number of protons. If you find the atomic number, you will get the number of protons. Simple. So now check, and because in this example the number of protons is 6 I have taken, right or not? Okay. So number of protons 6 means what? Atomic number 6. Now check in the table which atom having a atomic number 6. See, this is your carbon. Okay. See here, 6. This is your carbon atom. It means after seeing the periodic table, we found out this is the carbon atom, and it means these 3 atoms are different version of carbon that have different number of neutrons but the same number of protons. And these type of atoms are called isotopes to each other. All 3 are isotope. Okay? I hope the term isotope and mass number totally clear for now. These all are isotope. These all are isotope. This one. All 3 atoms of the same element having a same proton number but different neutron number. All 3 are isotope. Clear everyone? If any doubt, ask me in the comment section. Okay, I will reply. No worry. Now see, if I say in our world, in our nature, there are billions, trillions of trillions carbon atom, right or not? And out of trillion carbon atom, if you pick out one carbon atom, it could be either of these version. If you have, we know that there are billions, millions, trillions of trillions carbon atom in our nature, and out of trillions carbon atom, if you pick out one carbon atom, and that carbon atom could be either of these three versions. It could be the atom having a mass number 12, it could be atom having a mass number 13, it could be atom having a mass number 14. Clear? Right. So now see, I will give a very simple example, okay? Suppose here we have 100, suppose if you just pick up 100 random carbon atom, okay, 100 random carbon atom, 100 random carbon atom. So out of 100, you will get 99 carbon atom of C12, and one carbon atom you will get of one carbon atom of 13C, okay, and almost zero carbon atom of 14C. This is the thing I want to explain you. If you pick out, if you have 100 random carbon atom, right here 100 random carbon atom, and if you pick out, in this 100 carbon atom, you have 99 carbon atom of having a C12 and one carbon atom having a 13C. That means neutrons here, how much? Here neutrons how much? Neutrons is 7, and here neutrons are 6, and here neutrons are 8. Okay, so out of 100 random carbon you have taken, and out of 100 there will be 99 carbon atom in which number of neutron will be 6, and out of and one carbon atom out of 100, that atom neutron will be 7, and almost zero carbon atom of 14C, that is having a neutron number 8. Okay, now see, now do the maths. Okay, now do the maths, simple math. Okay, suppose you have carbon, right? So there is a possibility of three versions of carbon. One is C12, one is 13C, one is 14C, right? And this C12, the percentage of C12 in the nature is how much? 99%. Okay, 99%. And the percentage of natural abundance percentage of 13C is how much? 1%, approx 1%. And the 14C almost 0%. Almost 0%. It means it is a very rare. Okay, na 14C is a very rare, and it's a very very highly unstable. Okay, the more stable is C12 and C13, right? And almost 0, and here is rare. It found in the trace amount. Trace amount means like 1 part per trillion. 1 part per trillion. This means what? It means if you have trillion carbon atom, okay, and if you in that trillion carbon atom you have only one carbon atom which is having a 14C. Only one carbon atom you will find of 14C, having a neutron number 8. Okay, clear? Now, now the question arises from here that what is the atomic weight or atomic mass of carbon? Right or not? Because some of the carbon having a weight is 12, some of the carbon having a weight is 13, some of the carbon having the weight is 14. So what is the average mass of carbon? What is the average mass of carbon? You might think just taking the average of this 12 and 13 and 14 divided by 3, you will get the average atomic weight or average atomic mass. No, that is wrong. Here you are totally wrong. See here, if you are thinking like this, कि sir, I will take average of all the carbon here, like 12 plus 13 plus 14 by 2, and you will get here 39 by 2, that is approx 19.5. But this is wrong. 19.5 is not the mass of carbon, not the average atomic weight of carbon. This is wrong. Okay? Understood? This is totally wrong. Clear? Okay. Because why we cannot do like this? Because here the carbon percentage is not same here. This carbon is 99%, this carbon is 1%, this carbon is 0%. So we cannot add simply like this and taking average by 3. Sorry, it is a by 3, okay? By 3. Hey, this is a by 3, okay? Understood? This is a by 3, okay? So if you add this all, 12 plus 13 plus 14 and divided by 3, you will get 13. Okay? But this is not the correct mass. This is not the correct average atomic weight or average atomic mass of carbon. This is wrong method. This is wrong method to find the average atomic mass or average atomic weight of carbon. Why? Because all the carbons here are not present in the equal amount, in the equal percentage. This carbon is present in the 99%, this carbon is present in the 1%, and this carbon is 0%. So that's why we cannot do like this. Simply adding and taking average will not give the answer. Okay. Now see the correct method. Okay. Now see the correct method. Correct method to find the average atomic mass or average atomic mass, average atomic weight, both are same thing, okay? Or average atomic weight or atomic weight or atomic mass. How to find? See, first of all, let me clear you. Mass number is simply, there is lots of difference between the mass number and the atomic weight or atomic mass. Okay, understood? First of all, mass number is just simply number of proton plus number of neutron we do. And mass number is valid only for a specific isotope, or we talk about individual atom. Like here, this atom having a mass number how much? 12 AMU. This atom having a mass number how much? 13 AMU. This atom having a mass number how much? 14 AMU. These are not the atomic weight. Okay, understood? These are the mass number of a particular atom. Okay, if I want to find the atomic weight or atomic mass, then we have to take the average. Understood? then we have to take the average of the atomic weight of all the isotopes. Clear? So see here. So let me write here. Uh, okay. So here, how can you find the average atomic weight or atomic mass for carbon? See, we have to take a percentage also in the calculation, 99%. And here, what is the mass of this one? 12, right? And how much percentage? 99. So 99% of 12 plus. Then we have here 13C. How much percentage? 1%. And what is the mass number of this atom? 13. So mass number into 1%. So 1%, 1% into 13 AMU. Okay. Here also write the AMU unit. Write the unit AMU plus this C14. It is almost 0%. And the mass number is how much? 14. These are the mass number. Okay, understood? These are the mass number. Be careful. These are the mass number. So 14 into 0. 0% of 14. 0% into 14 AMU. Now, and this is your what? This is your average. This is your atomic weight, or you can say atomic mass. Or atomic mass, or average atomic weight, or average atomic mass. All are same thing. Very, very important. All are same thing here. Okay? All are same thing. Atomic weight, atomic mass, average atomic weight, average atomic mass, all are same thing. And we have to take a percentage of all the isotopes. Okay? And now, if you do the calculation here, then you will get 99 by 100 into 12 AMU plus 1 by 100, because this is the percentage, into 13 AMU plus 0 by 100 into 14 AMU. And from here you will get 99 into 12 AMU plus 13 AMU plus 0 into 14, 0. So here 0 AMU and divided by 100. And after solving this, you will get approx 12.01 AMU. And this is your atomic weight of carbon or atomic mass of carbon. Very simple, okay? Understood? This is your atomic weight of carbon or atomic mass of carbon. I hope it's clear now. And this value, you can see here, this value is very close to 12, right? Because C12 having a more and more percentage. Understood? That is why this value is close. You can write it also. This value is close to C12 because C12 has more percentage abundance in nature. Okay. Like that, we have many examples of isotope, okay, but be clear, okay, write it again, note, atomic weight or atomic mass, these are both same thing, okay, but atomic but mass number and this one both are different thing. Okay, both are different. Very very important. Both are different. Okay, right. Now I will show some picture. Okay, there are some more examples of isotopes. I will paste it here. These are some examples of isotopes. You can see here carbon having a C12 and a C13, but C14 very rare case, so that's why here not mentioned here. Okay, and hydrogen having a 3 isotope, that is a 1H1, and this is a 2H, and we have one more, that is a 3H, that is a radioactive and very less percentage, that's why we are not considering that one. Okay, similarly we have nitrogen, this is having a 14N and we have 15N, and their percentage also given here in the natural abundance is given here of all the atoms, those having a isotopes. Okay, see the fluorine has no isotope, only F19 exists. Okay, see the iodine also has no isotope, only I-127 exists. Okay, so this is the chart you can refer, and these are the natural abundance of isotopes commonly found in the organic compound. Okay, you can note it down in your notebook. Now see the last question for this lecture. I am taking only one question here, last question. After this concept will be over. So write one question. I will just copy this question, okay, from somewhere. Yeah. So this question I will copy this, okay. I already prepared this question. Okay. Now this is your question. An element X have isotope X20, X21 and X22. The percentage abundance of X20 is 90% and the average atomic mass of element is 20.18. Then what is the percentage abundance of X21? Very simple question. Go step by step. Okay, how to solve this? See here. We have some element X and this X is having a 3 isotope, right? First is X20 and second is X21 and third is 22, right? And this isotope percentage is given here 90%, okay, 90%, and this isotope we don't know, right? This one and this one we don't know, right? But we know that total X is what? How much? 100%, right or not? And 90% is X20. Then how much it is remaining? 10%, right? 90 plus 10, how much? 100%. Simple. So we'll suppose this is the X percentage, this is your X percent, and this become 10 minus X percent. Right. Now apply the simple logic how to find the average atomic mass. Average atomic mass, I told you, right, how to find. Simply just take a percentage of each isotope into mass number and add all. Okay, so here this X21, this X20, the percentage is given here 90, so 90% into 20 AMU plus you have plus X percent into 21 AMU plus 10 minus X percentage of 22 AMU, right? Now if you solve this one, and here in the question given, average is given here 20.18. So take this 20.18, okay, and if you solve this, 20.18 equal to 90 by 100 into 20 AMU plus x by 100 into 21 AMU plus 10 minus x by 100 into 22 AMU. And from here you will get 20.18 equal to 90 into 20 AMU plus x into 21 AMU. Just simple maths, okay? You can do it from yourself also, into 22 AMU by 100. And now from here if you calculate, you will get x equal to 2%. X equal to 2%. And this is your answer. It means this x is how much? And they are asking x 21. It means this x21 is how much? X21 is 2%, and then we have x22 how much? So 10 minus x, right? And x equal to 2, so we can find the 10 minus 2. It will become 8%. So it means you have 8% x22 and 2% x21 and 90% they have already given. Okay, so this is all about the atomic number and atomic mass and isotopes. If you found this helpful, hit the like button, subscribe to Chemistry Portal, and leave a comment with your questions. See you in the next lecture. Thank you everyone. Thanks again.